Alrighty, it's time to make a parser. Ha 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 ha. I'm making my H file right now. Hello, welcome back to me, building a compiler for a language that doesn't really exist yet. Last episode I got the basic start of Elixir finished, although there is much refactoring to be done. And this time I'm going to try and make a parser. And what exactly is that? Well, basically the Elixir from last time takes the text input, the source code, and generates a one-dimensional list of tokens which get fed into the parser. The parser takes those tokens and figures out which ones go with which other ones. So for instance, like a plus b to the Elixir just looks like 3 tokens, an identifier, an operator, and another identifier. The Elixir doesn't actually know that those tokens are one expression or how they interact with each other. The parser takes those tokens and figures that shit out. Basically, it has to look at the list and go, here's an identifier. What does that mean? Well, nothing on its own, so what's next? It's a plus, okay, then there's another identifier, so that's an addition, operation, that kind of thing. And then it constructs a tree made of nodes that represent all the things the program will do. So an operation like addition would be represented as a node with 2 children for the operands. Each node has to keep track of its own type, in this case it would be an addition operator, so that the compiler will know what to actually compile the parsed tree into. So I start out on this by defining a node type that we'll use to keep track of the nodes the tokens are parsed into. Next, I'm going to loop through all the tokens we got from the Elixir and check what type of token they are, then attempt to parse them. The first thing I'm going to do is make the int declaration node, since that's the first thing in my example. Yep, that's me. I bet you're wondering how I got myself into this situation. Awful code structure, barely any error handling. What gives? Haha, haha. Yeah, I didn't even do my research on this stuff. So, while writing the script for this, I realized, hey, maybe I should Google stuff so I can explain how all of this works and make sure I'm not spreading misinformation. So then I Googled some stuff, and then I realized, I should probably redo some of this, most of it, actually. So I'm gonna do that now. I'm gonna go through some concepts here that I want to try and implement, and then I'm gonna do it. What we have right now, right, we've got the parser is literally looping through all the tokens, which it will do still, but I'm literally just I just have if statements that's checking for all the things, and this is really bad. It's just not expandable. I'm gonna have to, this will result in a lot of copy-pasted shit code. So what would be nice is if I could externally define a set of rules for how my tokens are parsed, and then read that set of rules in and just sort of loop through stuff to check if a certain pattern is met. So here is what I'm gonna do. What I'm going to use is something called a context-free grammar. This is a set of rules that defines how my language is organized. It works off of a system of what are called symbols, which is kind of like a token, but unlike tokens, symbols can also be made up of other symbols. There are 2 types of symbols: non-terminals, which are made up of other symbols, and terminals, which are just kind of there. For example, in C, a statement is non-terminal because it can be made up of many other things like keywords and expressions, but an identifier is terminal because it's just made up of itself. You can't expand an identifier to a more detailed expression. On screen is an example of how a context-free grammar would be used to parse a simple if statement in C. The blue symbols are non-terminals and the red symbols are terminals. The box on the right contains the list of rules that governs this grammar. Of course, that's just a small subset of C's grammar, and my language's grammar will also contain many more rules than this example. But we can start small. So my plan here is I'm going to create a file that holds these rules, just a text file, and then I'm going to write some code that converts that grammar into what's called a CST, a concrete syntax tree. It's just a representation of the grammar in tree form. So it makes it easy for the program to loop through and go, okay, what do I have? Is it an expression? Is it a statement? What is it? And then check the children. Point 3, maybe I'll be able to actually save all of the terminals to use in the Elixir instead of having to check through everything like we're doing now. And then yeah, we'll use the concrete syntax tree and loop through it to parse into an AST, which is an abstract syntax tree, which is like it's a representation of our code as opposed to how it's parsed. All right, so I'm gonna start out by making a grammar file. And I'm just going to define my rules. Okay, so I've written out my grammar. This is what I'm gonna use for now. So what I wanna do basically is take all this stuff in my grammar file and turn it into a tree. Then I got to work on the grammar file reader. There was a lot of indecision here. I doubled back on a lot of my ideas, so it's kind of hard to talk about exactly what went on in my head as I was making it. I made some changes to my grammar format as well, but I'll talk about that in some kind of summary video in the future. Now the actual implementation. I have a hash map that keeps track of the nodes of my syntax tree by their names. I populate that map with nodes representing each of the terminal and non-terminal symbols. That's the first pass. Then there's a second pass where the reader goes back through the file and connects up all the nodes. I have to do it this way because I don't want to worry about how I order my grammar rules. It's sort of like how a language like C# allows you to call a method that hasn't been declared yet in a file, but C requires you to do a forward declaration if you're doing that. I'm taking the more user-friendly but slightly slower approach. Now I don't want to go crazy explaining the ins and outs of this system because it's honestly pretty basic stuff. It just took me a long time to implement because it's C, and me no good at C, but I'll go over some of the stuff I had trouble with and how I solved it. One thing is that my hash map was getting a lot of collisions. If you don't know how a hash map works, it converts some key value into an integer that is used as the index to an array of values. Using this system, you can use arbitrary data like strings or any made-up data type really to index into an array. It's pretty useful. But you have to watch out for collisions, which basically means that multiple keys are trying to put their values in the same index. In other words, multiple of my strings were being turned into the same number, so they were overriding the previous data at that index. To fix this, I just googled a proper hashing function implementation for strings and slapped it in there. Thank you, Java documentation. Very cool. Another issue was that my map was just an array of nodes when it actually needed to be an array of node pointers, so that I could allocate memory for the nodes separately from the map, since I wanted to free the map's memory at the end of the reading process. That was relatively easy to fix, just adding an extra asterisk here and there. Also had some fucky-wuckies in the memory department. Typical segmentation fault moments. Took like an hour and a half to fix everything, but it kinda works now. I think I might still have a memory leak, so I need to make sure I'm freeing everything, but for the most part this is a working system. Next time I'll make sure all my memory leaks are gone and that I'm null checking all my pointers, and then I'll see if I can integrate this system into the parser.